Here it says a perfect square is a number that is the square of an integer. The first three integer perfect squares are 1, 4, and 9. So 1 times 1 is just 1, and we see the square here. 2 times 2 is 4, and so we see that this square has a side length of 2, and 2 times 2 gives us the area of 4. 4 is a perfect square. And lastly, 3 times 3 equals 9, right? So those are the first three integer perfect squares. Likewise, the square root of a number is a number that, when multiplied by itself, equals the original number. The radical symbol is used to denote the non-negative square root. That last part's a little confusing. Let's look. So they're just saying what they call the radical symbol, or the square root symbol, shows that here it says square root of 4, right? And when I look at that, I know, oh, that's 2, right? Because that's the number when multiplied by itself gives me that number. Likewise, square root of 9, I look at that and I know that's 3, because that's the number that, when multiplied to itself, gives us 9. So you probably have heard of perfect squares and square roots before. My question is, what is the square root of 10, right? I have 9 here. I know that's 3. I wonder what the square root of 10 is. I have a calculator here. It doesn't have a square root button, but like I know 3 times 3 equals 9, and so like if I multiply it by itself, it should give me, I'm looking for something that would give me 10. Right? 10 is close to 9, so here, let's try like 3.1. 3.1 times 3.1 equals, well, it's closer to 10, but that's not, like, I want something that equals 10. I might need 2 decimal places. All right, 3.1, let's try 3.16 times 3.16, just kind of estimating here. Ooh, that's really close, 9.98. That would like rounds to 10, but I want it to equal 10. All right, I'm getting a little frustrated. I'm going to use a different calculator that has a square root button. I just want to know what the square root of 10 is. Wow, that's a lot of decimal places there, right? So if I multiply by this itself, it should equal 10. I'm going to check that. So 3.16 was what we had before. Then they're saying 2, 2, 7, 7, 6, 6. All right, I'm going to multiply all that by itself, right? Should equal 10. Wait, what? It doesn't come out as 10. It's like 0.99999999989, right? That's not 10 though. That's like super close to 10, but not 10. What's going on here? Well, so we've been talking about rational numbers. You might remember repeating decimals versus terminating decimals. Integers, square root of 9 comes out to be 3. That's an integer. What about the square root of 10 though? This is an irrational number. It is not a rational number, right? So rational numbers can always be expressed as a fraction using integers, and they can either terminate or be repeating decimals, right? This is what we've been converting back and forth between the two. Irrationals can never be expressed as a fraction using integers. They never terminate as decimals, and they never repeat as decimals. Let's look at some examples here, right? Here is a rational number. This is negative 81,572. That's a rational number. That could represent how deep in the ocean, how many feet deep in the ocean something is, right? Square root of 11, like the square root of 10, is irrational. 11 is not a perfect square. If we tried to take the square root, we get a really long decimal that never repeats. For instance, let's take a look at this number. This is irrational. Long decimal, we see a lot of 6s and 3s, but if you look at it, the pattern doesn't repeat, right? 6, 3, 6, 3. You would expect a 6 to come next, but that doesn't happen. And then we get 3 3s here. This is non-repeating, but it goes on forever. That's irrational. Whereas square root of 16 is rational. 16 is a perfect square, and that would come out to equal 4.